Hello. So it's been brought to my attention that some of my students are having difficulties understanding how to draw Bohr atomic models, and an extension of a Bohr atomic model is a Lewis dot diagram. So first of all of these models they're just simple ways to describe um, the placement of subatomic particles in an atom. More specifically, it's the Bohr atomic model that does that. So it's the Bohr atomic model that describes the placement of subatomic particles in an atom, namely protons, neutrons, which are located in the nucleus, and then electrons are found in respective electron shells that surround the nucleus. The Lewis dot diagrams are simply diagrams that just show the number of valence electrons in an atom, which is just the number of electrons in the outermost shell specific to that atom. So here we have a picture of the periodic table, and for our purposes, we're going to look at the rows and the columns. Um, Mostly the rows, however. So the columns that go up and down simply indicate the group, okay, or the family. So there's group 1 that runs up and down here, group 2, group 13, group 14, 15, 16, 17, right up here until noble gases, group 18. Okay? And what's important for us for the drawing Bohr models is that we use the periods, uh, which run horizontally. Okay, so there's period 1 from hydrogen to helium, and period 2, lithium to neon, period 3, 4, 5, 6, 7, and so on. Okay? So the thing to realize is that the placement of these subatomic particles follow that pattern on the periodic table. So for every period, there's a certain number of atoms of elements that you will find, and that will tell you the maximum number of electrons that are allowed in the shells. Okay, so for example, here we have hydrogen and helium. There are only 2 elements there in that period. So when we draw the Bohr atoms, the Bohr models, we're only going to find a maximum of 2 electrons in that shell. Okay, and since it's the first period, we are only going to find 1 electron shell. Second period, we're going to find 2 electron shells. Third period, 3 electron shells, and so on. Okay, so let's just do some of these here, and it'll help clarify, I think, a little bit. So to make this a little easier to understand, all we're going to do now is just follow the periodic table and draw the atoms of the elements, the first 10 elements on the periodic table. Okay, so what we're going to do is the first step I usually do is I just collect all the information that I need, which is directly on the periodic table, and then I calculate the number of neutrons, and then I just proceed to draw my Bohr model of the atom that way. Okay, so first one we're going to do is hydrogen, which is there. So hydrogen has 1 proton, has an atomic mass of about 1.01. It's got 1 electron, and it's going to have 0 neutrons. The reason why it has 0 neutrons is because the atomic mass is made up of the number of protons plus the number of neutrons. We neglect the mass of the electron because the electron is so much smaller in comparison to a proton or a neutron that it does not significantly add anything to the mass of the atom. So what we do is we take our atomic mass, which is about 1 for hydrogen. Oops, I don't know why it's doing that. Sorry. 1 for hydrogen, and we subtract it by the number of um, protons, which will give us 0 neutrons. Okay, so we'll start drawing the Bohr model here. There's our nucleus, 1 proton, 0 neutrons, and we're in that first period, so we're going to have 1 electron shell, right? And we only have that 1 electron, so there's hydrogen. Now we go to the next element, which is helium. Okay, so all we're doing as we're proceeding throughout the periods of the periodic table is we're adding protons, right, as that atomic number increases. Okay, and as we add protons, we're changing what the elements are. So then that will impact what they look like. So as we proceed, we add protons and we're adding electrons as well. So our next one is going to be helium. So helium has excuse me, an atomic mass of about 4, okay, and it's going to have 2 protons. So that means its number of neutrons is going to be 2. So we're going to have our nucleus right here. We have 2 protons, which we get directly just by looking at the periodic table. The atomic number tells us what the number of protons are. And we calculated 2 neutrons as there. Okay, we have 1 electron shell, and we have 2 electrons. So we're going to draw 1 electron there, and another electron there, and we're done with helium. Now, the next element on the periodic table is going to be lithium. But if we notice that it doesn't go beyond the noble gases, right? It doesn't go beyond group 18. So it has to go down 1 period, excuse me, here. So because it changes periods now, to make room for that extra electron, we have to add an electron shell. So let's do lithium. Lithium is going to have an atomic mass of about 7. Okay, so I am rounding these numbers up. That's 6.9 according to my source, but I got 7 minus the number of protons is going to be 3. 7 minus 3 is 4. So we're going to try drawing lithium now. There's a nucleus. We got 3 Okay, so we're going to go ahead and use our periodic table here to draw the Bohr models of these atoms. So the first thing I want to write, I'm just going to write down over here, this part over here, what the formula is for finding the number of neutrons. Okay, so the number of neutrons is just going to equal to the atomic mass subtract the number of protons. Okay, so I'm just going to put number of protons. Okay, so that way we have it there for our reference in case we need to learn it. Okay, so I'll put a number sign here. Number sign. Okay, so we're going to do hydrogen right here. So hydrogen is in that first period, so we know it's only going to have 1 electron shell. It's only going to have 1 electron. It has 1 proton. So I'm going to go ahead. I'm going to draw the nucleus right here. Okay, well, it's a large nucleus, but that's okay. Actually, let me change that. Wait. Cool. Okay, so then draw the nucleus right here for hydrogen. Okay, 1 proton, and it's got 0 neutrons. How did I get that? Well, the atomic mass of hydrogen is about 1. Okay, and it's got 1 proton. 1 minus 1 is 0. Okay, it's going to have 1 electron, so I'm going to draw an orbit right there and draw my electron, and there's my hydrogen. Now I proceed down the periodic table to the next element, or the next atom of the element, which is helium. So helium is going to have 2 protons, okay, and it's going to have 2 neutrons, which I didn't do a good job drawing, but that's okay. How did I get that? Well, the atomic mass of helium is about 4, right? So I got 4, and I'm going to subtract it by the number of protons, which is 2, and I get 2 neutrons, and I'm going to get that 1 electron shell because we're still in that first period. So first period, right, and 1 electron shell, and then there's 1 electron, and then 2 electrons. Now the next element is going to be helium. If you look at the periodic table, there's no room past group 18 for lithium to be placed. So it's not going to have just 1 electron shell. It's right here in the next period, so it's going to have an additional electron shell, period 2, meaning it's going to have 2 electron shells, which makes sense because we have to make room for that extra electron as indicated by the atomic number. Strictly speaking, the atomic number gives you the number of protons, so because we're assuming all the atoms of the elements of the periodic table, on the periodic table I should say, are stable, the number of protons are going to equal the number of electrons. So let's go ahead and draw lithium. So we added 1 here, electron, 2 electrons, now we're going to add 3. So we're just adding electrons, pretty much, and protons to the nucleus. Okay, so here is for the nucleus for lithium. Oops. Oops. Okay, so we got 3 protons. Okay, 3, this is a 3 by the way. Okay, I don't know why it's disappearing. So 3 protons. The atomic mass for lithium is about 7 atomic mass units. Subtract 3, it's going to give us 4 neutrons. So I'm going to go ahead and put 4 neutrons here. I'm going to go ahead and erase this part here so I can make room to make my orbits. Okay. Alright, so then here we go. So we're going to have that 1 valence, right? Right, we have to have only 2 electrons here. That's the maximum number of electrons that can go there. Why? Because in that second period, which is helium. So if you look at this and you just ignore the nucleus, it looks like helium, right? Which is right here. So we have to put that inside every Bohr atom or electron configuration that we're going to do from now on. But we have to make room for that other electron, and it has to come from a second shell. So the maximum number of electron shells that can go into that first electron, the maximum number of electrons that can go into the first electron shell is going to be 2. Okay? So that's lithium. Right? The next one is going to be beryllium. Beryllium now has 4. So we're going to have 4 protons. Okay? Okay? Beryllium has an atomic mass of about 9. 9 minus 4 is going to give us 5 neutrons. Okay, so here's our nucleus for beryllium. Okay, we have our first electron shell, 2 electrons. Okay, and then we need to add 1 more. Oops, it's not very good, but oh well. We need to add 1 more electron there from lithium. Okay, so there you go. This looks like lithium now, but because it's beryllium, we have an extra electron, and that's beryllium. Okay. So all we do as we proceed through the periodic table is we keep adding. We keep adding the electrons. Okay? That's all we keep doing. And we keep getting these configurations. And that's all you need to do to construct Bohr models. Okay? So I'm going to go ahead and I'm going to draw the rest. And then I'll explain to you again. And then we'll do the Lewis dot structures. Okay, so we'll continue on with the Bohr models for elements in period 2. I'm going to draw boron, carbon, nitrogen, and neon for you. I skipped oxygen and fluorine just to keep the videos a little bit shorter because my videos can get long. So again, I just put all the information here, gathered, did the calculations, and so I'm just going to fill in the electrons now. So we've got 5 protons in boron, so we're going to have 5 electrons. So again, just fill in the electrons. Maximum number of electrons for that first shell is always going to be 2, no matter. Okay, there you go. And then we have 3 more electrons. So we got 1, 2, doesn't matter where you put them as long as you spread them out. Okay, 6 protons, so 6 electrons here. For carbon, 2, 3, 4, 5, 6. So all I'm just doing is I'm adding electrons. And it follows the same pattern as the periodic table. Okay, I know my diagrams are not the neatest, but what's important to understand is how you do it. Okay, 1, 2, okay, we go 3, oops, 3, 4, 5, 6. Okay, now I'm going to stop here for a second and explain something to you. So the maximum number of electrons in this first shell here we've been talking about and doing is 2. And that's because we have a maximum of 2, or we only have 2 elements, or 2 atoms of elements, I should say, in this period. So we won't be able to go beyond 2 electrons. Why? Because these atoms are stable. And the number of electrons are going to equal the number of protons. Okay? So that's the maximum number of electrons that can go here. If we want to fit any more electrons, if we want to draw Bohr models for lithium and beyond, we have to get another shell to make room for those electrons. Okay, so if we look at the number of atoms of the elements in this period, we got 1, 2, 3, 4, 5, 6, 7, 8. Okay, that means that there will be a maximum number of 8 electrons in this second shell. Okay, so now we've done 4 for that outer shell for nitrogen. But 4 plus 2 only gives us 6 electrons. So now we need to start adding more because we need 1 more electron to get 7 electrons in total. So when you get 4 here, they actually start to pair up. Okay? You might be thinking, well, why is it that electrons, that they have the same amount, it's the same kind of charge, don't they want to spread out as far as they can? And the answer is yes, they do. But with more advanced kind of physics and chemistry, they actually occupy these orbitals in pairs. And the reason why they're able to is because they're in different spin states. As far as my knowledge of chemistry goes, they're in different spin states. So we start to pair them after we get 4 of them spread out. Okay, so we're going to put it doesn't matter where you put it, but I'm always going to start from the top. That's just my preference. And so we put 1 more there, and now we've got 7. Okay, so that's nitrogen. So I skipped oxygen and fluorine, and here's neon. Okay, so again, neon has 10 protons. It's got 10 neutrons. How did I get 10 neutrons? Well, the atomic mass of neon is 20. 20 minus 10 protons gives me 10 neutrons. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So at this point, I'm going to explain how to do the Lewis dot structures. My video is getting a little bit longer. I'll do this as quickly as I can. So neon here has the maximum number of electrons allowed in this outer orbital, okay, which is 8. Right? So a Lewis dot diagram is going to deal with, okay, it's going to deal with only the outermost shell. Okay, so Lewis dot diagrams are only going to be concerned about the outermost shell of the atom that you're interested in. So Lewis dot diagrams or Lewis dot structures are a lot easier to do than Bohr models, because all you need to do is just worry about that outer shell. Okay, so let's do one for boron and for neon, and you should be able to understand and apply it to the rest. So how we do it for boron is we just write the symbol in the middle like this, and we count the number of valence electrons. 1, 2, 3, and we draw them out. And it doesn't matter where you put them. 1, 2, 3. And there's your Lewis dot structure. For carbon, we got carbon. We look at the outermost shell. We have 1, 2, 3, 4 valence electrons. So we go 1, 2, 3, 3, 4. And there's a Lewis dot structure for carbon. Let's do one for neon. Neon has a maximum number, has a full octet. It's called a full octet. Okay, got a number of it's got 8 valence electrons. So we're going to go ahead, draw neon. 1, 2, 3, 4, 5, 6, 7, 8. And there's the Lewis dot diagrams. Okay, I hope this video helped you understand things a little bit better.